Okay, this is lesson 5.2. So if you want to just go over the things that we did, or if you've missed, 5.2 starts with talking about corresponding parts. So if you look it up in the book, this is from page 240 in the book. It says, remember that two geometric figures are congruent if and only if a rigid motion or a composition of rigid motions maps one of the figures onto the other. So if you think about chapter 4, when we moved one triangle by rotating or reflecting or translating, we ended up with two congruent figures. And remember, those two congruent figures, the angles were still congruent, the sides were still congruent. That's a rigid motion. Okay, so the rigid motion keeps the length and the angles the same, but then you have the corresponding parts of those figures that are going to match up. So that means each of the sides will go with a specific side, each of the angles will go with a specific angle. So if you look at the picture here, if DEF is the image of ABC after a rigid motion, or a composition of rigid motions, remember one rigid motion would be a translation or a reflection or a rotation. A composition would be doing more than one of those. Once you have those two triangles, you now have parts that are the same. So the corresponding parts are the angles that go together or the sides that go together. So then we went over the theorem 5.3, and remember when we talked about segments and angles, we said reflexive was just a mirror image. So same thing on both sides of the congruency. We said symmetric was dealing with, it didn't really matter which side you were on. You could say triangle ABC is congruent to triangle DEF, or you could turn it around and it would mean the exact same thing. Triangle DEF is congruent to ABC. And then we said transitive. We talked about it with sides or angles, but it also works for triangles. So if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then you can drop the matches and triangle ABC is congruent to triangle JKL. Okay, next theorem is the theorem 5.4. It says if two angles of one triangle are congruent to two angles of another, then the third angles are also congruent. So if we have two congruent triangles, A, B, C, and D, E, F, if we know that A is the same as B and D is the same as E, for instance, I could put 70 in angle A. I could put an 80 in angle B. That means because of the congruencies, angle D is also 70 and angle E is also 80. So if I add my 70 and 80, I get 150. So 180 minus 150 is 30 degrees. So that makes angle C equal to 30 degrees. And then this theorem just says if these two angles match on both triangles, angle F has to be congruent, or has to be equal to, no congruency, sorry, equal to 30 degrees. So it just says if you match two triangles that are congruent and they have two angles that are the same, really the third angle has to match. Okay, so we're going to go and look at some examples. So pretty much extra practice, we're going to identify all the pairs of congruent corresponding parts. So we're going to identify angles that go together, and we are going to identify sides that go together. So in exercise 1, again, we have a congruence statement. So remember, this is a congruence statement. It tells you what goes with what. So in the case of first letter here, angle P is going to be congruent to angle S. In the case of second letter, angle Q is going to be congruent to angle T. And in the case of the third letter, angle R is going to be congruent to angle U. Okay, then you can pretty much also do the sides based on that. So again, first two letters, side PQ is going to be congruent to ST. Side QR is going to be congruent to side TU. And then side, I guess if you're walking around PQ, QR, then you're going to go RP is going to be congruent to, so if we're doing RP, we have to do US. So these would be the congruent corresponding parts. So angle to angle, side to side. Okay, if you look at number 2, we can do the same thing. Now we have 4 sides and 4 angles. So angle A is going to be congruent to angle E. Angle B is going to be congruent to angle F. Angle C is going to be congruent to angle G. So first to first, second to second, third to third. And then angle D is going to be congruent to angle H. Now, that takes care of the angles. And again, then we can do the sides the same way. So AB is going to be congruent to EF. BC is going to be congruent to FG. CD is going to be congruent to GH. And then again, either order, AD is going to be congruent to EH, or DA, it seemed to make more sense to people, is going to be congruent to HE. So again, this is listing all your pairs of corresponding parts. Now, it did say please write another congruent statement for each one of these. So we started PQR to STU. You have to go around the edge of the picture. So if we change it to be QRP, our second statement has to start with whatever was congruent to Q. So we'd have to start with T. Our R was congruent to S. So it would be a different order for this. Could be QRP is congruent to TUS, and again, it doesn't have to be. You could do RQP or any of the other orders as long as you're going around the figure. Same thing with this one. You have to go around the figure. So if we went A, B, C, D, we could certainly turn it in reverse and go A, D, C, B. We could do D, C, B, A. We could start anywhere as long as we're going around our figure. So if we started with D and went around this way, we could say D, C, B, A. And if that's the order we go, then we have to start with the letter that was congruent to the D. So H. Then we went to C, so we would have to say G. Then we go to the B, so we would have to say F. And then the A is that. So again, this is just another order. There are multiple ways you can rearrange that. Okay, if we take a look at exercise 3, now we really only have one set of sides and one set of angles, so we're only going to need part of this. So in the case of this side XZ, we know by looking at this that it's first and last letter, so XZ is going to be congruent to RT. So if we know XZ is 15, then RT, we don't know. So we have to decide how we can find RT. So right now, these are congruent. It's an isosceles triangle. So if this side is 3y plus 9, this side has to be 3y plus 9. So RT has to be 3y plus 9. So we solve this normally. So 6 is equal to 3y, and y is equal to 2. Okay, now we look at the x's. The x's are inside. These were outside, so they have to be sides. These are inside the triangle, so they have to be angles. So if we look at angle y down here, angle y is the middle letter, so angle y has to be congruent to angle s. So if angle y is worth 2x minus 20, and angle s is worth 30, we're going to just solve from there. So add 20 to both sides. So 2x is equal to 50, or x is equal to 25. Okay, if you look at number 4, we're going to do the same thing. But now we're only dealing with angles. So angle A has to be congruent to angle E, and angle C, and it's because these are the only ones we know, are A and C. C has to be congruent with the third one, or angle G. Okay, so we're going to set up the A to E. So angle A is worth 60 plus 8x, and angle E is worth 108. So we solve it normally. 8x is equal to 48, so x is going to be equal to 6. Okay, again, we have the other part, so C is going to be the same as G, so C is worth 62, and angle G is worth 8y minus 3x, except for we now know what x is. So 62 is equal to 8y minus 3 times 6. So 62 is equal to 8y minus 18. Okay, we solve normally, so plus 18. So 8y is going to equal 80. So y is going to equal 10. Okay, so there's 4. So we had to put just angles because we had only inside information. Okay, next page. Now we're dealing with show that the polygons are congruent. Okay, and we haven't done this yet, but I'm just going to go over it, and then you'll have something to look at if you do not understand where we're at. Okay, right now we have angle A is congruent to angle C based on our figure. We also know that AD has the same markings as CD, so AD is going to be congruent to, if I start with the A, I have to start with the C, so CD. I also know that this piece is congruent to that piece, so if I say AB, it's going to be congruent to CB. And if you look, BD is shared by both, so actually BD is going to be used on both triangles because it is a shared side. So if we look at this, we know that if we walk around one triangle, okay, and again we can start anywhere, but we could say triangle ABD, so that would be this top one, and then if we want to write our second order triangle, we can look at what we know. We know that angle A is the same as C, so we have to start with C. We know side AB is the same as CB, so we have to go to CB. And we also know that BD is the same as BD, so if this ends with D, this has to end with D. So they're congruent because we have these matching parts, and actually we have one angle left, so third angle theorem would say those two have to be congruent, so the triangles are sharing all of the sides and angles. Okay, if you look at number 6, your polygon, again, pretty much you have sides and angles you can match up. So angle M is going to be congruent to angle I on the other one because they have the same matching symbols. Angle L is going to be congruent to angle H. Angle N is a right angle to angle G, and angle K is also a right angle to angle J. Now, let's double check that these are okay. So N has a 3 and a 1 piece, so we need the angle, the 90-degree angle that has a 3 and a 1 piece. Okay, so that means we're going to have to change this. So look where we're at. So N is between a 3 and a 1, so its matching angle has to be between a 3 and a 1, so we need to change that one to a J. Okay, if we look at K, K is between a 2 and a 1-sided marking, so angle K has to be congruent to something that's between a 2 marking and a 1 marking. So here's my 2 marking, there's my 1 marking, so this one actually has to be G. So you have to be a little careful and look at the sides that are coming into the angles. Okay, that means we can rewrite this. So if we start here, we could say M, N, K, L. So we just walked around the figure, and then we can look up here. So M is congruent to I, so we have to start with I. N is congruent to J, so we'd have to go to J. K is congruent to G, and L is congruent to H. So we could say M, N, K, L, so we would have to say I, J, G, H. And again, you can write this in a different order. Okay, if you look at number 7, we're just going to pull it apart, so we actually have 2 triangles. We have triangle A, B, C, and we know that this is a right triangle, and we know that that has a marking up there. Okay, we're going to slide the other one out of there, so we have D, B, C. And if we look, that has a marking like that, so we can do that. This has a right angle, so we can do that. And now we can kind of put another number in the other triangle. So this angle D was a 33, so that means we can make angle A a 33. Okay, so if we know these 2 angles, we can always find the third angle C. So angle C, which would be this one right here, is going to be 33 plus 90, or 9 times 123. So angle C is going to be 180 minus 123. Okay, so angle C is going to be 57. Okay, that means if this is a 33 and this is a 90, that's also going to be 57. So we're trying to find angle 1. So we know that this little triangle here has an angle of 57 on this side, just this piece here. And we know that this little angle B has a 57 there. So the whole thing is the 90, but the little part of it here and the little part of it there are 57. That means we can find this angle here. So we're going to do, let's see, so we're going to do 57 plus 57. So 7 7 is 14, 5 5 is 10, 11. So we know that these two angles here are 114, so that means we can find the top angle by doing 180 minus 114. So 180 minus 114. So this top angle is 66. Okay, so we just use the triangle sum theorem. Now we're going to figure that angle because we have a linear pair. So we're going to do 180 minus 66. So 180 minus 66 is going to be 114. And again, angle 1, you could find that two ways. You know that this part's a 57, so you could do 90 minus 57. Or you know this is a 114 and this is a 133. So 114 and 33 is 147. So 180 take away 147 is going to be 33. So angle 1 in this case is 33. So you either found it by using the triangle sum theorem, or because you found that this was a 57, you could do 90 minus 57. So it's up to you. Okay, last thing, we're going to fill in what we know here. So we have a vertical angle, so this becomes a 54. Angle 1 is congruent to, or angle X is congruent to angle U because they have the same markings. And if we have a 54 and an 80 here, we can find that one. So 80 plus 54, 8 and 5 is 13. So 134. So if these two are 134, we're going to do 180 minus 134. So 180 minus 134. So this angle is going to be 46, and because it's congruent to that angle, we're going to make it a 46. So angle 1 on this side is 46 degrees. So that takes care of your practice for 5-2.